Hey guys, so we're continuing off with 1.2 solving equations and inequalities, and we're just going to go over some basic properties here. So, properties of equality again means equation sign. Now, inequalities would be less than or equal, or greater than or greater than or equal, so that's something to note. Now, you all remember the addition property of equality. What you do to one side, you have to do the other. So if you add one side, you have to add to the other. So yeah, same rule applies with the property of inequality. Okay. The only difference between the two here is the symbols. You have again equals and you have less than. So that's something to note. Now, subtraction property of equality. You can subtract the same numbers. So again, if you subtract a constant term, you would have to do it to the other side. Now the same thing applies to inequalities. Subtract by a constant term, you have to do it to the other side. Again, the only difference here is the symbols. Okay, one's an inequality, one's an equation. All right, so multiplication property. If you want to multiply one side, you have to multiply to the other. Same thing happens with inequalities. You have to multiply to one term, you have to multiply to the other. But something to note, this statement will still stay true, but if you multiply by a negative, okay, to both sides, your symbol will change. Okay, it actually flips. So remember, if the number is negative, so if the number will be negative, it will be the opposite. So it flips. That's one of the special cases. Oops. Let me scroll back down. So this is one of the special cases to definitely remember. Okay, division property of equality. So if you divide one side by a constant number, you have to divide the other side. We all know that. Okay, so let's see. If we divide by a constant term on an inequality, a positive constant number, all right, same thing happens. You divide what you do on one side, you do the other. Now, if the number is negative, so here's another special condition. If the number is negative, the symbol will flip, it'll change. Okay, so that is also something to note. It's like this. It's like 5 is greater than 4. Okay, I'd rather eat 5 hamburgers than 4 hamburgers. But if I changed it to starving for 5 hamburgers as opposed to starving for 4, I would rather starve 4 hamburgers worth than 5 hamburgers worth. So the symbol changes because the logic changes. All right, so we're going to use these properties. So here's our first example. We're going to have to, well, this is given to us, okay, for the justification. And it looks like we use the subtraction property, okay, to get to the next step. So these canceled out, and then this gave you the 20 right there. We would have to use the division property. But remember, how to get rid of a multiplying negative 4? Divide by a negative 4. And what you do to one side, do to the other. So that's division property of equality, which is stated right here. And you get the symbol to change. So again, this was our little special condition, okay, that happens to our inequality symbol. So x is greater than negative 5. And basically, this is the narrative. So basically, we had our equation, negative 4x plus 3 is less than 23. Then negative 4x is less than 20 by properties of inequality because we did the subtraction of 3. Then we use division property, and then we get x is greater than negative 5. And that was our answer. Let's go ahead and solve this equation. If you want, you can use the symmetry property, symmetric property, and that will just flip everything over. So 3x plus 5 equals 11. You could do that. If not, you could do that later. It's up to you. So again, this was the symmetric property of equality. Use the subtraction property. And again, that was the subtraction property. Let's go ahead and use the division property, because how do you get rid of a multiplying 3? 3 divided by 3 is 1, and all you have left is 1x, and 6 divided by 3 is just 2. And that's the solution. Okay, and pardon me, I totally forgot my last property, division property. So you might see something like this where on a test they'll ask you to solve for a problem, and you have to explain all your steps. Okay, here's my first step, second step, third step, and I got my solution. Now you could always double check your solution by plugging it back in. Okay, so this is again substitution. Okay, so originally we had 3x plus 5 equals 11. We said that x is 2, so we're going to plug it back in. 3 times 2 is 6. 6 plus 5 equals 11. And that's actually true. So that checks. That works. That's x equals 2 is definitely our solution. Okay, so a great way to double check. All right, number 10, slightly different, but kind of the same in the sense that we're trying to isolate x. Well, let's get rid of that plus 4 by using the subtraction property. Again, we're working on getting x by itself. So again, this is the subtraction property of equality. So we have x divided by 3 is greater than 7 minus 4, which is 3. How do we get rid of a dividing 3? By multiplying by 3. So this is the multiplication property of equality. And 3 times x to the 1, or x 1/3, is actually the same as saying 3 divided by 3, which is 1. So you have x is greater than 3 times 3, which is 9. Okay? And this is our solution. If you want, we can double check. Again, that's by substitution. And we had what? Originally we had x let's see, over 3, so that'll be 9 over 3. Again, I'm substituting for x here. 9 divided by 3 plus 4 is greater than 7. Hopefully this is true. 9 divided by 3 is 3. And 3 plus 4 is 7. Is 7 greater than 7? That is actually false. So that's actually, let's take a look why it's false. So if we were to graph this, okay, I know you're like, but it's supposed to be true if it's a solution, and that's actually right. So if I was to graph x is greater than 9, we would come across this conversation. Here's 9, but we just plugged in 9, but it's false. Well, that's because it's not equal to, so it's a hollow point. Now x is greater than, so we would fill in to the right, going towards positive infinity. For example, 10 would be greater than 9, but 9 is not greater than 9. So 9 would not be a solution, but everything else above 9 would be true. Okay, so that's a great example of why x has to be greater than 9, because we checked and it gave us false, and that explains why it's hollow. Okay, because it's false right there. Everything else is true going on towards infinity, and everything else to the left, like 8, would be false. All right, so I'll tell you what, let's go ahead and try number 11. We could use the symmetric property. Negative 7x plus 2 equals 30. So again, that's the symmetric property of equality. Let's go ahead and use the subtraction property to get rid of the plus 2. We have negative 7x equaling 28. Let's use the division property of equality, because how do you get rid of a multiplying negative 7? Divide by negative 7. Negative 7 divided by 7 is 1. All you have left is 1, or 1x, or just, there you go, 1x, equals, and I believe this will be negative 4. 28 divided by negative 4. There you go. That'll be a solution. You could always double check, plug it back in. I'll tell you what, I'll go ahead and let you do that. 7 times negative 4 plus 2 equals 30. And then go ahead and continue on your work, and then raise your hand. Let me know. Let me know what you got. Okay, that way we can have a good little chit chat about it. All right, next up, we have negative 7 plus 2x is less than or equal to negative 5. Well, let's get rid of the term that's not with x. So the negative 7. How do you get rid of a negative 7 or a minus 7? What is the inverse of minus 7? Plus 7. What you do to one side, you have to do the other. Again, this is the addition property of inequalities in this situation. The negative 7 plus 7 cancel out. You have the minus 2x or negative 2x on the left still. And negative 5 plus 7 is the same as saying 7 minus 5, which is 2. And then how do you get rid of a multiplying negative 2? By dividing by a negative 2. And this is the division property of equality, or inequality, sorry. But remember, this is a special case. We are dividing by a negative. Therefore, our symbol has to change, it has to flip. And 2 divided by negative 2 is negative 1. If we were to graph this, okay, if we were to graph it, here's our number line. Here is negative 1, and it's a solid dot because it's not just greater, it's also equal. And then we shade everything to the right. And if you check it out, 0 is greater or equal to negative 1. That would be true. If you go to the left with negative 2 is not greater or equal to negative 1. All right, so let's get some independent practice. Let's look at this situation with a friend. Suppose a friend paid $16,368 for a car, and you'd like to know the car's list price. Now the price before taxes, basically. Okay, so list price means price before taxes. All right, so you can compare various dealers. Arizona, where the sales tax is 6 point. Okay, so how do we create this equation on the board? So your friend paid this much for their car. I'm taking it that they bought this car in Arizona. Now, if they bought this car in Arizona, that means they paid a sales tax of 6.6%. Well, we know that, for example, your friend here paid $16,368, okay, on a car. Well, she also had to pay 6.6%, and that's 106.6% of the original cost, but we're looking for the original cost before taxes. So we would take 100% minus the 6.6%, and if you actually did this in decimals, you would get, again, our original out-of-door cost before taxes. And now we have 1.00, the 100%, minus the 0.066, that's the 6.6%, and that would equal the list price. Okay, so let's try this out. We have 16,368. Let's go ahead and use our calculators, because calculators are a tool. We have 1 minus the 0.066, and we actually end up getting 0.934, which is really just 93.4%. And if you multiply that to our $16,368 car, you get a smaller number. That's our list price. It is $15,287.712. But with context, we're talking about money, so 15,287.71 cents. So that is our list price. Okay. So notice how this is out the door cost. Okay, that means somebody paid taxes. Your friend lives out in Arizona. Taxes was 6.6%. So you can tell that from your list price to your out of door, there's a big difference in money there, big difference in cost. So some people buy cars in different states sometimes. It happens. That's why these states charge money sometimes just to register your car in a different state. All right, so now describe to a partner how we can isolate the variable and solve. So again, we were looking for the list price. We know that we had the original cost of the car, or out the door cost, okay? And we were looking for the list price. So this is 1 minus the tax, and I'll just say percentage equals the list price, or original cost. Okay. So if you were to actually try this out to get something different, if you were to isolate for the original or the final cost, you would be looking at something a little different, but we'll talk about that in class. All right, so New York, where the sales tax is 8.25%. Let's see, so the equation is going to be this. Let's say your final cost equals the price plus 8.25%. Now, this is really just the cost equaling 100%, or 1.00 of the price, plus, and if we convert this to decimals, again, percentage to decimals, it moves there, so you would have 0.0825, and that'll add on to our price. Combine like terms. So our cost will be 100% plus that 8.25%. So whatever our price is, we have to multiply it by 1.0825. So we just combine 100% of whatever our cost is to 8.25, and we combine it as our coefficient for our price. So I'll tell you what, let's try this. Find me the cost if you were to pay $1,000 on, I don't know, a computer or something, with the tax. Okay, so you have $1,000 purchase, so that is your P, but now you're multiplying it by the tax. So you have 100% plus the 8.25%. So you could also say price, and this is what you use in the calculator, 100 plus 100% plus the 8.25%. So find me the cost after taxes for a $1,000 computer. So go ahead and plug that into your calculator. Again, P is the 1,000. And this over here is after the taxes. All right, so we're going to move on. Purchase price of a car in is, okay, so we're going to look this up. And we're going to experiment with that in class. Okay. So Zachary is planning to send a video game to each of his two brothers. He buys the same game for both his brothers and pays $4.75 to ship each game. How much can he spend on each game without spending more than $100? Write and solve an inequality for the situation. So why would he want to use the inequality for the situation instead of an equation? Well, because he might have some extra change and more than. So, okay. So is it possible he's going to spend a little less and have some cents left over? Yeah, it's possible. So basically it's this. He pays $4.75 per game. Okay, so number of games. And he can't spend, let's see, on each game without spending more than. Okay, can he spend more than? No. Can he spend less than? Yeah. Can he spend exactly 100? Maybe, we don't know yet. Write and solve an inequality for this situation. So this is the inequality I just wrote. Okay, this is the rate, okay, of how much it costs per game. And he can spend $100, but he can't go over it. So that's why it's less than or equal to. Okay. Now we're going to solve for part C, which basically just means we're going to use the division property. And what we do to one side, we do to the other. Let's go ahead and plug this into our calculators. We have 100 divided by 4.75, and we have n is less than or equal to 21.05. So in real life, this would be two possible game prices Zachary can pay and still be in his budget. Let's see, so this is actually 21 games. Okay, Zach can be below or equal to 21 games, and he should be okay. So if you were to graph this, and that's what part D is talking about, he's got 21 games. And you could spend that much or below that. Okay, so could he spend 20 and still be within his budget? Can he spend, get 5 games and still be within his budget? So answer that for part D. Okay, and then lastly, what about 25 games? Would that work? And that's what they're talking about. All right, so equations. Let's see, x equals 5. That's right here. That's the only place that it could be true. Now x is less than 5. Okay. Oops, I made a mistake. There we go. Erase. X is less than 5. And I did it again. Wow. For some odd reason, I really want to just draw that point. There we go. X is less than 5. So it's not equal to 5. So it's not at 5, but it's less than. Okay. And that's what I just graphed right here. So this is false over here. 6 would be false, but everything else here would be true. Okay, so that's how to read inequalities for graphs. So if we solve for the following here, we have to subtract the 4 to both sides using the subtraction property of equality. These cancel out. You have 3x equals 12. We'll use the division property of equality. divide by 3, both sides, and x equals 4. So if I was to plot that, say this was 4, and that would be the graph for that situation. Now on the number 16 problem, if we were to use a subtraction, notice how the equation is very similar, or the inequality is very similar to the last equation. The only difference is the less than or equal to. So same properties as earlier, just for inequalities, and x is less than or equal to 4. So here we are at 4. Okay, that could be true. And if it's less than, that also would be true. So that's the difference between graphing an equation on a number line and an inequality on the number line. So I'll tell you what, go ahead and try 17 for homework, 18 for homework, and honestly, I think this whole page, 19, 20, 21, the other 21, and that'll be good for today. All right, guys, have a good day, and let me know if you have any questions, okay? All right, thanks.